Right. This is on PROFINET gateways, and these are the devices that have been developed to connect PROFINET to other types of network, mainly because there's a large number of networks out there, PROFIBUS being one of them, and nobody anytime soon is going to start stripping that lot out. So they're trying to facilitate the idea of a gradual migration for those people that's interested in it. And this slide that I showed you before tells it all. For PROFIBUS on the left, I'm sure you'd see something very similar to all of the other older technologies, that there are some industries that are sticking with it, but otherwise they're generally moving over to this idea of an industrial Ethernet solution, PROFINET in our particular case. Just might be worth mentioning that PROFINET is just one of several industrial Ethernet protocols, and this is the one that we are, is the natural one to migrate to from PROFIBUS. So, for those of you that haven't used PROFIBUS before, then basically there are some main components in here. We have I/O controllers, the PLCs, similar to a PROFIBUS master, but we call them I/O controllers here. These are the guys that are going to be configured for cyclic exchange with your process, the guys controlling the process. We have I/O devices in the PROFIBUS world called slaves, but in the PROFINET world called I/O devices. These are the remote I/O, the drives, the valves, etc., etc. Then we have switches, and I mentioned before, many companies make these switches. We have this one here from Phoenix, Siemens make them as well, but they also cater for what their customers ask. And most of their customers ask for unmanaged switches, and that's what they sell them. And then we have a problem from a support point of view, as I've mentioned, and that really can't be understated. It's not that PROFINET won't work with these unmanaged switches, it's simply that they do not have the ability to provide us with diagnostics, which will be a problem in both qualification and fault finding in the future. We have monitoring tools. These are the guys that are going to be used for auditing a network, going to also be used for fault finding. But as I mentioned before, very constrained by the use of unmanaged switches in that network. And then we have gateways, and these gateways basically used to connect to other types of network. They might be older ones like PROFIBUS, ARSI, CAN bus, but it also might be a requirement to link to this IoT, the industrial Internet of Things, getting additional data from these plant-based devices. So this is generally not the role of the PLC. The PLC generally is a cyclic controller interested in controlling the process itself. IoT is basically acknowledging that a lot of these devices, if you've ever configured a drive, you'll know just about the sheer number of parameters that you can have in a drive. Well, there may be a benefit in actually getting that data out and coming up with a more informed decision of what's going on in the process at a higher level. That's what we're going to look at with these gateways. So, there's basically, we have a term gateways and couplers, and there doesn't seem to be a formal PI definition that I've been able to find. So what I've written on here is my definition rather than PI's. First of all, they're physical devices, they plug into the network, and they generally facilitate communication between two industrial networks. At least one of them are going to be PROFINET. In my opinion, PROFINET gateways generally act as an I/O device on the PROFINET side, but on the other side, they are some kind of master. So, for example, it might be an I/O device on the PROFINET side and a PROFIBUS master on the other side, or an ARSI master and things like that. That's generally, when you look at what all these devices are called, gateways tend to fall into that category. Couplers are slightly different, and they, from my experience, they tend to interface two separate networks, but both networks are identical. Now, where I've used a coupler in the past is where the client has had an existing PLC system already doing its job, and I was given the task of writing a program, a PLC program, for a small skid-based process control system. So I developed all my network completely independent of the client, and then we sat down with the client to discuss what information did he need from me and what information did I need from him. And basically, that is how we configure a coupler. And I'm going to show you that shortly. So on here, on the PROFINET side from a coupler, the gateway will appear as an I/O device. And like its predecessor, PROFIBUS, we have what's called GSDML files. These are files primarily used by the configuration software, and these files contain everything the programming software needs to know about a given device from a PROFINET point of view. So, for example, is it a modular-based device? If it's a modular-based device, how many modules are available and what particular options do they have? If he's able to generate diagnostics, for example, loss of 24-volt power supply, those words literally appear in the GSDML file. So fundamentally, we need a GSDML file for every PROFINET device that we're going to want to communicate with. And ultimately, it's used for incorporation into the hardware configuration of the I/O controller. Gateways then are available here for a wide range of combinations: Profibus DP, Profibus PA, RZ, and so on, as you can see on here. I/O link that was mentioned before as well. Clearly, the need to have a gateway between PROFINET and Profibus PA. Profibus PA is generally used by the process industry, where typically temperature probes, level probes, etc. The need for them will slowly be removed as this new technology, PROFINET PA, gets launched, APL as it's known in the wider industry. There's many manufacturers of these devices. We've got Helmholtz, Phoenix, Softing, IFM, Comtrol, ESD, and surprisingly, I've not put Siemens on there, but they are there somewhere on that slide if you look closely. But basically, many organizations produce these devices, and every one of these is going to need to be configured into the hardware configuration of the respective I/O controller. So let's have a look at the first one, a PN coupler. This is a device from Helmholtz. It's got an RJ45 or 4 of them, but the idea is on the left is network A and on the right is network B. They are completely independent PROFINET networks, but there is a need for information from one side to pass to the other. It might just be the pressing of a start button or some diagnostic information. So on the left, we have this network 1. We have a controller. We have a Vargo device as a remote I/O device there. He will look at the left-hand side of this coupler just as another I/O device that is able to present analog and digital information, and he can send it as well as reading it. It's almost like a multi-channel analog input, analog output device. On the other side, we have another PROFINET network with its own controller, with its own devices. Neither of the controllers know of the existence of the other network. They are only passing information through that particular device. In terms of configuring it, then basically we need to get hold of the GSDML file. And the GSDML files, they are created by the manufacturer, and they are unique to the device that you are working with, or the type of device. So if you've bought 10 of these, you will need one GSDML file for that device, and you will import it 10 times. If you've got 10 different ones, you need 10 different GSDML files. You drag it into the hardware config, and this is a very small aspect of that. You get a visual picture of it and the cable connecting to it, and you tell it the name of the controller that you are going to link to. In the PROFINET world, we don't have node addresses. In Profibus, it was used to be node 10, node 20, and so on. In the PROFINET world, very different. We have to give the guy a device name, and he has to be assigned an IP address. By default, The only thing the user should need to do is give it a name. The I/O controller will have been configured that once he finds the guy by name, he will allocate the IP address. This is how, if we double click on that device, this is how it appears. It appears as though we've got modules, and in here, I've configured this, that on this, from the left-hand side of this device, it's going to appear as being able to provide 64 bytes of input, and also has 64 bytes of output. What those inputs and outputs mean is between me and the system integrator on the plant. I'm defining what the bits and bytes mean. I'm just allocating data slots. That's the only data that gets transferred between the two sides. So what we have to make sure of, in this case, you can see I've got 64 bytes of input and 32 bytes of output. So on the other side, I'm going to need to make sure that I've got 64 bytes of output and 32 bytes of input. The exact opposite. On one side, it's an output channel. On the other side, it's an input channel. This looks very similar, again, from Helmholtz, and this is basically a PROFINET to PROFIBUS DP coupler, basically to facilitate communication between a PROFINET device and a PROFINET network and a PROFIBUS network. Now, this is a coupler. I'm going to show you a gateway later on. There is a significant difference. If I show you this, then basically we need two configuration files because they need to appear in the respective I/O controller or the master. So the GSDML file will be used for the configuration of the PROFINET I/O controller, and the GSD file will be used for configuration of the PROFIBUS master. In both cases, neither network knows of the existence of the other side. Generally, what you can see on here, we've got some dip switches at the bottom right, these blue switches. They are going to set the Profibus address, and the Profibus master will just talk to this guy as though he is a conventional Profibus slave. So, in this case, we've got a network with its own Profibus master, with some Profibus slave, and he needs to be told there is now an additional slave to communicate with. On the other side, we've got another I/O controller, another PLC, talking to a drive, and he's going to have to see that he's got an additional I/O device. So we've got the PROFINET network thinking he's talking to an I/O device, and the Profibus network thinking he's talking to a slave. And the device itself facilitates the transfer between the two. Very, very straightforward to set up. On the PROFINET side, we need a GSDML file, so we drag this guy in here, and again, we set it up so that we've got X bytes of input and X bytes of output, and this is basically either you, your system integrator, discussing what information do I need to transfer between the two networks and what do I need to read for the other side. So it's clearly going to differ on a case-by-case basis. On the on the Profibus side, we have to get the GSD file. And it's exactly the same thing, but we're doing it in a physically different device. So this is one way where if you've got a Profibus network now that's already working and you don't want to change it, but you would like the idea of maybe installing a new separate, smaller PROFINET network, this is an ideal device of linking the two together and gradually migrating towards PROFINET, which eventually you're going to be forced to for one reason or another anyway. That was Profibus DP. If you're not conversant with Profibus, there's two forms of Profibus, Profibus DP and Profibus PA. Profibus DP is generally found inside cubicles. They require a separate 24-volt power supply in addition to the cable. That's very general. You can have Profibus devices going outside, but generally they're going to be mounted on a DIN rail inside a cubicle. They use what's called RS485 as the electrical transmission method. PA is very different, and that was designed several years after DP to address the idea of replacing 4 to 20 milliamp devices. If you've ever worked with 4 to 20 milliamps, you'll know that you've got two conductors, and that is power and data over the same cable. Well, that's what you get with PROFIBUS PA. Now, as it stands today, we do not have an Ethernet solution to PA as it stands literally today. But the technology has been developed. The likes of Endress & Hauser, Pepple & Fuchs, etc., and many, many other companies have developed this such that you can basically run 10 megabit full duplex communication over the existing PA cable. So that's going to be a big change and may start to make the people stuck with Profibus move over. So on this guy, this is a bit different because basically this is going to act as a PA master. And clearly the devices on the PA side are going to differ from application to application. On some, we might have all temperature probes. On another, we might have a mixture of temperature, pressure, level, etc. So the configuration of this is going to be very much application specific. And basically what it's going to require is an application-specific GSDML file to be created, because the actual device, the PROFINET controller, needs to know what information he's going to get from these PA devices. So here's our PROFINET network that talks to this guy as though he was just another PROFINET I/O device. But down here, we've got these various PA slaves, Profibus PA slaves. Somehow, we have got to configure the guy in the middle to say, downstream of you are these devices. And the only way we can do that is to create a an application-specific GSD file. And this is the software that you get. It comes with the device, and all you need to do is basically make sure that you've got the GSD files for all of the Profibus devices, and you literally drag them in, and they will be assigned an address. You might just be able to set there, it says Profibus address 2, and so on and so on. That's all you do. You do that for as many Profibus devices as you have on the Profibus PA network. That will create a GSDML file unique to this application. You will then import that into the I/O configuration of your PROFINET I/O controller. It appears like this in the hardware configuration. ARSI is still a very popular network, especially in the factory and automation. If you've ever seen it, it tends to be the flat profile yellow cable. Very, very, very popular, where the advantage is you can literally connect the devices into the cable by screwing them directly into the cable. It's very, very basic. It's not a replacement for Profibus. It tends to be used at a lower level than Profibus. But it's the guys that we would typically find on there are stop buttons, traffic lights, maybe basic solenoids and things like that. Certainly not things like drives or anything like that. And they're available in various forms. We can get PLC modules that have got an ARSI interface, or you can get devices that are standalone and facilitate that. So here we've got some from the likes of Siemens on the right. You can see that's a plug-in module if you've got an S7-1200 PLC. Then we've got Bill and Wiedemann and IFM. P&F do all of these as well. They're all very, very similar to set up. They have to be supplied with a GSDML file for, again, inclusion in the configuration of the I/O controller on the PROFINET side. So this is not writing software, this is simply advising the I/O controller, these are the devices that you need to communicate with, and this is the information that you're going to get from them. So it's fairly straightforward. If you've done it once, you'll be able to do it very easily on other times. They're certainly easier to configure than Profibus, etc., because there's no GSD files for ARSI. It's a kind of a fixed format. So a lot easier to do there, and basically the slot numbers dictate the physical address of the device. So if you've got ARSI and you are thinking of maybe incorporating it into a PROFINET network, there are many manufacturers around that would facilitate that as well. In the Siemens world, then we literally drag the individual devices onto the hardware config. The yellow is something that the TIA portal software does for you. So a number of options there for you in that case. Then we have something called IO Link. And IO Link is predominantly aimed at the factory and automation. It's going to be things like you'd typically find on an ARSI network, to be honest. Buttons, traffic lights, those kind of things. So by definition, it sits downstream of PROFINET. But it's ultimately taking this idea of Industry 4.0 down to the literal simple physical bits and bobs on the network. So these are what the devices look like. So we've got two that connect to a bulkhead mounting, and each of those ports on the orange device, the 8 ports, each of them would connect to one IO Link device. We can't daisy chain on this, it's point to point, and we can have basically 20 meters of cable downstream of each of these ports to the respective device. The 2 ports at the left, the top left and the top right, well, they are the PROFINET ports. So that's what we have there. There's one in the middle, again. The one on the right is a Siemens, again, a module specifically for the Siemens S7-1200. They do it in a slightly different way, but the outcome is absolutely the same. Standalone devices on the left have to be supplied with a GSDML file. They have to appear as though they're just some kind of I/O device on the network. And this is basically what IO Link is all about. We have at the bottom left, you've got an S7-1500 PLC here, and he happens to be connected to this IO Link master. And this IO Link master facilitates the interface between PROFINET and these kind of devices. So infrared level sensors, proximity detectors, buttons, simple lights. They're very, very different. And this is quite a well-established technology now, taking you right down to the very lowest level on the factory floor. And then finally, we have IIoT gateways. And this is basically saying there's information on my network that I want to pass not to another PLC, not to another network, but maybe to a server. Whether that is a locally based server, whether it's a cloud-based server, but the idea is that you want people to literally get that data. And if it's not clear what this is all about, the best analogy that I tend to give is my car, just to make sure that you're clear on this. When my car was a year old, I was watching a video waiting for the car, and it basically said, download this app for your car. Bearing in mind my car was a year old at that time. And I downloaded this app, and all this information came up on my iPhone in terms of where I'd been, the fuel level, the AdBlue level, my brake level, all this really interesting stuff. And I thought, wonder why they've been doing that for the last 12 months when I didn't even know, I hadn't even paid for it. And then I realized that in essence was an example of Industry 4.0. That's going back to the car manufacturer. Now, they're not interested in my particular car, but they're probably very interested in my model of car. What they may do is also bring in data from their service departments. They may also bring in data from the Highways Agency. And they may also bring in data from the Met Office. Now, I'm making that up, but it's mainly to give you the idea, because that data, which has got nothing to do with controlling my car, somebody at a high level could start to look for correlation between all of this and said, have you realized that when this particular model of car made between this date is driving in this terrain and the ambient temperature is this particular part keeps failing? They would not know that just by looking at the car itself. And now the industry that we live in are starting to wake up to that idea. And there's one large food-related factory that I can think of that have actually taken that decision, and they've said, from now on, we don't want anything fitting onto our industrial automation network unless it follows the principle of Industry 4.0. In other words, they think that this additional data is going to be able to put them at a competitive advantage, maybe improve product quality. And that's really what all of this Industry 4.0 is all about. It's not something that the PLC is particularly interested in. He's still interested in the normal cyclic control of your plant and the sequences and the PID loops, etc. Clearly, some PLCs, the more powerful ones, will facilitate getting this data, but it's not their prime role in life. And there are two main protocols that we tend to see when we're talking of IoT. Some of you will know of OPC. OPC's been around for the last 30 years and was predominantly developed for transferring information between SCADA systems and DCSs of different manufacturers. But that still applies, but OPC-UA is particularly targeted at data associated with Industry 4.0. And there's two main types that people use, either that or MQTT. MQTT started off really as a kind of a home-based automation, but now is being found in the industrial automation world. I know Siemens have modules for both of these. This particular one here can do the same as well. But this is not communicating with a different control network. This is communicating either with a different controller or a higher level server, so that somebody can start to correlate all of this information and make a decision at a much higher level that doesn't include the control of the process. So, as it says here, the main use is either for machine-to-machine communication or machine-to-cloud. Cloud being some kind of server. And as I've mentioned there, MQTT and OPC-UA are the most common protocols that are being used. And there's many PLCs that are getting into this. You'll also notice that a lot of the diagnostic tools that are available now have OPC-UA interfaces, because people like the idea of being able to get the diagnostics out of them and put them at some higher level SCADA screen and things like that. So I'm just going to give you a bit of a demonstration of a product that has just recently been launched by Phoenix Contact. This is a device. This is a PROFINET to PROFIBUS gateway. The one I showed you before was a PROFIBUS to PROFINET coupler. This is slightly different. You can see it's a DIN rail mounted device. It's got two ports, one to connect it to PROFINET, the other one to connect it to PROFIBUS. All you need to do is give it 24 volts and then connect the appropriate cable to those particular ports. But this is different in that this does not require a Profibus master on the Profibus side. In other words, this is going to allow you to make use of your Profibus slaves on a PROFINET network. All of the intelligence, all of the control is in the program residing in the PROFINET IO controller. So it's slightly different. The other one, we assumed that you already had a master. And basically, this is the setup that we use in the training. On the top left, we have a PROFINET rack, and you can see that there's top left, a little grey device. We've got a Siemens S7 1200 controller. And what I've done is I've configured the program in that PLC to communicate with these three slaves, these three Profibus slaves that we use on the Profibus training course. There is no PLC in that bottom right-hand rack. Those devices are specific devices. The one at the top right is a Siemens ET200, the one at the top left is a Vargo, and I think the one at the bottom right is a Fraber encoder. But they're Profibus devices. By default, PROFINET can't talk to them. But if you imagine having a large amount of Profibus devices already existing, this device from Phoenix Contact is going to allow you to get some life out of them yet. What I'm showing you here, don't know if you can see this at the back, but these are basically the specifications from a Profibus point of view. And one of the things that every Profibus device in the world has is what's called an ID number. It's the way in which a controller can check that the device at a given address is the right kind of device. Just having an address doesn't tell him it's the right device. This is how he's going to do it. And for those of you who can't read this at the back, but the top left-hand one requires a GSD file called Vargo B760. So his ID number, which is burnt into the memory of the device, needs a GSD file with the number B760. The Siemens guy in the middle needs a file called SIEM80F3. 80F3 is the PI defined ID for this particular ET200. And then at the bottom, we've got the Freiber encoder, and he happens to have an ID of 4711. What we've got to do is configure this Phoenix device to make him aware that these are the physical devices that you need to communicate with. So, let's have a look at that. If I come out of here for a minute. Let's bear with me a minute. Right, so what I have first of all is, if I just find it on here. First of all, let me show you the program, or the configuration program that comes with the device. Let me get this back on here for you. There we go. So this is basically the software itself on here. And what it's asking me on here is asking me what am I about to configure. I can load an existing product, or I can just say, I want to configure a PROFINET to PROFIBUS DP gateway. So if I click this box here and click OK, it now wants me to tell it what what Profibus devices he needs to communicate with on the Profibus side. And all that I've got to do on here is literally import a GSD file. I've got to point it to the folder where all my GSD files are, and all that I have to do is scroll through this list until I find the right ID number. Now, I won't do all of this now, but you'll get the gist on here. I can go down here. B760, I remember, was one of them. I click on that, and I click OK. And he's put him there. All that I've got to do now is repeat what I've done X number of times, one per device, to build up this picture. And what I then have to do at the end of it is I will then export it as a GSDML file. That's all I've got to do. If you've got the GSDML files for the devices, this is as difficult as it gets. You create the GSD file, you can completely close this now. That is finished with. And what we can then do is, if I go on here, we're then going into the world of Siemens on here. Now, I did have Siemens opened, so bear with me. Wait a few hours while I start TIA Portal. That will mean a lot to those of you that have used TIA Portal, so bear with me a minute. Okay. Right, so this is now the programming environment of the TIA Portal. I'll open the PROFINET program that I have here. So this is one that was already developed for communicating with the devices in our development rack. I'm not interested in the software at all here. I'm interested in the configuration of the device. So I'm going into what in the old days was called the hardware configuration, and in TIA Portal is now referred to the devices area. I think it's devices and devices and network. I'm just going to click on this bit here. What you're going to see when I click this is all of the GSDML files. They could have just come through the door, couldn't they? Really, didn't have to drill. These are all of the GSDML files for the device in this this network, who this PLC is looking for. There's loads of them. But right at the very bottom, I have added the GSDML file that configuration software produced before. I have to tell this guy where I'm going to give him a name, but if I double click on here, then downstream of this device, he's got the potential of talking to up to 125 devices. And all that I have to do, over here on the right, you can see that it's created submodules specific to the devices that I have told this guy who he's going to communicate with. So he can see there's an ET200, and if I scroll down, it will show you all of the modules that the ET200 can support. Likewise, all of the one module that's this Vargo. So all that I've got to do is drag from right to left to populate this central area for a given device. That's all I've got to do. Save that, and now it's just a matter of writing code to write to these input and output bytes. Now that idea is how it works for almost every gateway. It fundamentally is no more difficult than configuring, dragging the GSDML file, and after that, it's a program aspect. So that was the device from Phoenix. Tony is here from Phoenix if you want to ask some specific questions about it. But that's basically it. There's gateways for almost everything, but it's all much of a muchness. And if you are not a Siemens user, it will be very, very similar in terms of how you would configure it. So, I'm supposed to finish at 11:35 and it's now 11:33. So you've got 2 minutes of questions. Any questions on that? They're just another device that will you don't have to go all for PROFINET. You can gradually migrate and try it out, if you like, with all of these bits of kit.